Good morning, sir. My name is Timothy Thomas George, registration number 20BC1278, Data Structures and Algorithms, D2 slot. My presentation is going to be all about trees. In this presentation, we are going to look at the applications of this data structure. We are going to have the following applications: file directories, database design, shortest role, dictionary, and compilers. File directories. This is a common observation that we see on the sidebars of our Windows Explorers. It's an organization of files. And since this may look a little untidy, I say, let's represent it with a tree. How do we do this? Let's take, for example, here we have the local disk and we have different folders inside it. So let's add a local disk, the C drive root node, and the 3 folders that are in it. Now, if we see, the users folder has 2 more folders, public and WinBR. So we can add these two, public and WinBR. And WinBR is further divided into folders such as contacts, desktop, downloads, favorites, and links. In this way, we get a tree representation of the file directories that we see in linear representation. The next, database design. Take, for example, these three tables in a database. We have a book table, we have an author table, we have a publisher table. And this may be the way that we are used to see it, but let's represent it with a tree. How are we going to do this? Let's take our book table. We have these 6 attributes in this one of a book. So we'll enter a book root node and we can put its attributes. But before we enter name, company name, and country, we remember that name, company name, and country are also in another table called the author. So we can represent it as such. We can add an author and then its attributes. And lastly, for the third data structure, the third table, which is publisher. And if we look, the ID attribute in the book table is a foreign key to the publisher, to the ID attribute in the publisher table. So we can represent it as such. Thus, we have now represented these 3 tables using a tree. Let's go to the next application. Here we have a map of India and different cities. We have Jodhpur, Patna, Surat, Raipur, and Madurai. And we have the distances between them. So let's say these are roads that go between these cities. And maybe you are someone who is thinking, well, if there's a road from, let's say, for example, Surat to Madurai and then Madurai to Raipur, then what is the use of the road between Surat and Raipur? So you might want to get the set of the roads that connect all the cities, do not leave any city disconnected, but is also the shortest road. And this is what we can solve this using a spanning tree. So here again, we're using a tree. So if we remove the India map and we just use the city names, using different algorithms, such as Prim's algorithm and Cluster's algorithm, we can find the minimum spanning tree, which will be the least cost tree that will connect all these different nodes. Next, let's go to dictionary. In dictionary, we have different words: cat, dog, deer, but this is a very boring way to represent. Let's represent it with a tree. How do we do this? Let's take the first word, cat. We'll have a root node. And then let's represent the alphabets in cat, C, A, T, as different nodes in the tree. So C, A, and T. Okay, that's done. Now the next one, dog. Again, D, O, G, three different letters we can represent in the same way as we have done for cat. Okay, let's take the next word, which is deer. Now, we could again take four alphabets, but when we look into our tree, we already have the letter D. So all we need to do is add on from that letter and put two E's and the R. So here we have stored these three words using a tree. Now we're going to talk about compilers. This is a segment of code while a greater than 0, if b equal to c, b plus plus. And I'm going to say, let's represent it with a tree. How are we going to do it? So let's go line by line in the code snippet. First was while a is greater than 0. So we'll need a while root node, and then we'll need the condition a greater than 0. Now we know that there are lines of code that come inside the block and inside the while. So we'll add a block compound, a compound node, and then to that we need to add if b is equal to c. So in the same way as we had done for a greater than 0, we can add if b is equal to c. Now if b is equal to c, we know that we have to execute b plus plus. And so we can put an operation and the operand onto the right child of if, like so. Thank you.